Okay, I made it to compile again. And I can run it, same thing as before. But yeah, I don't want to have to do this for each epsilon. I mean, I don't want to have this macro at all. I don't want to have this number, which is just fixing the maximum number of epsilons that we can use. Everything should be automatic. What else do we not want? Okay, that means you can't do this. Plus, I do not want variables really. Epsilons to be variables, rather. So we should not need these two functions here, converting between the two indices. This becomes a lot less. They should only store the variables, and so on and so on. But how to do that? Okay, so that means that variables here only deals with the user variables, like C0, C1, C2, C3, and X, but not the epsilons. And then here those are declared, which means I can use C3 and X here, because they are declared here. And I'm not using epsilons. Well, actually, now I am using an epsilon here. But it comes from the namespace variables. Plus, there is not really any need, I think, to do that. I can just pass nothing, and then have the FA class, the floating point round-off-error class, figure out, yeah, what the next free epsilon is, because each operation. So multiplication here, addition, multiplication, and so on. Each of those just needs an epsilon and a different one. So in the end, we are not going to pass the epsilon index to this constructor. Hello, Sogatron. It's really difficult to decide how to approach this. I could just start with deleting everything that I don't want to do, but then I'm not sure where I will get stuck. So I'm kind of meditating, as it's just looking at the code, and then hopefully you get a feeling. But I don't think there's that much else here, really. Hi, Matrix. Yeah. I mean, the only thing I'm doing is constructing new FA objects. Actually, I would not be able to do this anymore then. We need a provision to turn off epsilons. Still want to be able to do this. So here I have a minus that and a division that do not introduce a new epsilon. Yeah, I have to think about that. Good, so here's the tough stuff. We do need to be able to access all epsilons, but even I'm not really sure now then how many I have. It seems I need an object that manages all FA objects. It would be that object that takes care of the epsilons. Or you could propagate it, of course. Let's say this thing introduces a new epsilon, and then it's being used here. So if this thing that stores the information about its own epsilon, and it could have this one also store its information about its own epsilon, plus have a pointer to any other objects that have epsilons. In this case, that would be just this one, not the C2, but for example, in no example. No, but okay, it would be possible, of course. I mean, this would be an example. Let's just go down to where that happens. In this case, so the FA is an FA, and the DFA is also an FA. So this would then require two pointers in order to get the information of the epsilons from that one and from that one. It's damn difficult. Right, okay, let's just start with simplest case. The very first one. This line. Yeah, like an alternative would be like I create a manager. Let's say the epsilon manager. It would just be an object without being constructed. And then say the first one here would be created passing the epsilon manager. And so on, yep. But if we do this, then we can't, I mean, in the end, I want to replace this with just the multiplication. So we can just type in a formula and then get everything instead of this mess here. Let's say these two. What this is doing is it multiplying C3 with X and then adding C2 to that afterwards. So let's do plus C2. Escape. And it could just do auto, no, the result would still be that, I suppose. So this is what I want to do in the end. And now neither of these operations have access to the epsilon manager. It's just not managed. It's just not mentioned, I mean. But we do have, of course, the C3, the X, and the C2. So maybe I can add a pointer to the manager to each of those objects. And then you can only combine two objects that use the same manager, of course. But at least then we'll always have a pointer to the manager. And then also I do not have to declare the manager because I might as well automatically create one. How about it you just inherit a manager from each other? Let's say this object, whatever it is, does not have a manager, and neither does this one. But then if you try to multiply them together, it says, hey, I need a manager, and neither has one, so let's create one. And then it tells both this object and that object to use that manager. And then it's going to do this addition, and then this result does have the manager object. So then it says, oh, this one does not have a manager, and that one does have a manager. So I'm going to tell this one that we now know the manager. It must be the same manager. And the result object also has the same manager. So the manager is then generated on the fly and propagated. That won't work, however, if, for example, we do something like A plus B times C plus D. If A and B, if neither A and B and nor C or D have an epsilon manager, then this one create one, and this one will also create one. And then we have a different manager. And then I'm multiplying it. So for this to work, we would still have to be able to merge managers. So the code could detect, of course, that the manager of this expression is different from the one here. And then it just picks one. And it merges the two managers. And then, then tells those objects to use that. But then the C and the D itself would still be using the old manager. No, I don't like that. I'm making it too complicated. Instead, I suppose I should I think the users should create the manager, and then we use that to declare my symbols. So that will be happening here, and then every symbol, all 5 of them, already have a pointer to the epsilon manager. So okay, let's do that. So it means that I have here an epsilon manager, and then this was just example. Now let's pass it to this. Dude, shut up. No. This is not going to work, is it? No, it's not going to work. Maybe can make it work. Sure. So declare symbol now would have the epsilon manager passed, and that is this thing here. But it's being called with name. So now I need to change this thing into something that where we can pass a name to, which is not going to happen. Gonna work because we need a name literally. No. I'll just use the string directly. So it just uses the epsilon manager. Sorry, just have to call like that. I'm getting tired of this. Oh, this thing just it just creates symbols. That is not going to work either then. For each variable. I guess you can make this macro an variable macro. How do you call those things? I forgot how to do that. Hello, Davey. It is so annoying. Oh, I did it before, but now I have to remember where. So I want, if there are any arguments here, I want to pass them here. But if there is no arguments, I don't want to pass anything. And I think that is a problem in that if you pass nothing, then you probably just end up with something with a comma here anyway. So So you have to remove a trailing comma. It is almost impossible with macros. And I forgot how. Let's do some searching in my projects. I think it was VARs something. Yeah, at least that exists. So it's something with VARs. Let's just print the L, the file name. So I have a remove trailing comma macro already, so you probably need to use that. For some reason it's mostly external projects that have this. Not written by me. This is external, system D is external, of course. DNS is external. I think I'm going to stop this. I have enough. I don't want to look at external stuff, really. I want to look at my own stuff. Let's have a look at this one. And enums reflection. Did I write that? Debug set name. Let's have a look at it. Sure. This just pauses it. Hmm. No. Nothing works. That looks a lot like what I want. Passing a parameter. It's over my head. I wrote this, but really, what the F is it doing? I hate forgetting stuff. Generated. I edited it. Nou ja, it's not edited. Nobody's nobody's gonna be happy with this either, right? No. Okay, I think I'm gonna add this just here. And is it too difficult? I have to, I probably should rewrite or something. I mean, really start from scratch. Yeah. Yeah, I think that's what I have to do. So I'm starting over. That means that anything below my cursor does not exist. But we do need a variables index. That is going to be the index into utils array. Okay, containing the user variables. But I probably should also not have the user declare this. Why would I? So instead of floating point around of error.h, I can use the same header maybe. Yeah, so we added that as well, and then we're going to move this to this header, so I got rid of it. But that begs for some kind of namespace. Huh? That's my namespace, and then I need a new name for this class. I could call it expression. It represents an expression more or less. Yeah, we definitely don't have a number of epsilons. And I'm definitely not going to declare them. And this is then just my list of variables. In case I need it in multiple places, let's keep the macro. And I'm not sure I want to use the enum, really. It would probably be better to have simply an array with everything in it, and then always use the index into that array. I could use a for loop to run over it. Maybe I can or will declare something that I can use to... I could just declare, say, the indices with the correct names, and then use that name to have the index into the array. So if we can help it, we don't have an enum really. And this conversion I definitely don't want. Number of variables, okay. I do need to know how many variables we have. But yeah, guess I can use a count. Number of variables, okay, let's just do for each variable count. That means we need a count. That should work, right? So we have 0 variables, but if there is one of such line, then we get a +1. So basically this is 0, +1, +1, +1, +1, +1. So it's going to be 5. And then here, I think I don't want to store the symbols in the array. I just want to store the variable structs. So we just declare that first, and then put the symbol in here as well. Symbol pointer. And then here we just make an array with variable structs. So I'm not going to have declare variable then, or do I? Because this creates something that I can use in my program. So this is going to have some kind of name. Actually, it's literally going to be these names here. I want these things to exist in main so I can use them. And like I said before, maybe they should just be an index, or, well, yeah, they must be an index because now I store variables in the array. So yeah, I'm declaring variables in some namespace. But we already have the array, so now let's just be an index. So it's going to be the variable index. Why is it green here and not green here? Oh, there's an S missing. So now the name that we pass is going to be variables index, and that index has to be constructed from an int. And we can, I think by then the array should already be initialized. That would be the easiest thing. This is just an afterthought, so we have the name available in main as a local variable. So I'm going to assume that we already have the variables array. But then how can I access that? From name. You can't. Well, we were running over it. No, I just have name. Yeah, so my trick was that I did create the variables enum. So we can convert the name to some integer with this constructor. Just do the variables enum colon name, and that then gives me the enum, and then I can cast that to an int, and then even construct the variables index from that. So that would be a kind of dirty way to get the variables index. But let's do that anyway. So I know I want this to be the variables index, so I can just do it like that. To declare variable is now declaring a variables index. Let's make it a const even with that name, and then we know the value of the index because we use a variables enum, which exclusively is needed for this thing here. Pretty sure I already deleted it, but we're gonna need it again. Maybe we can go back and find it. Nope, that's not what I want. Okay, that was this. Which also gives me the count then. No. Where am I using this count now? Nowhere? Oh, I'm using it here. Yeah. But it's the, yeah, that's the number of variables. So let's use that then. So when I don't do this then, I just want to access this directly. How am I going to fill this thing? Global variables are pretty evil, so I don't like that it is global. Plus, you could initialize it as global right here, but yeah, no. I mean, if I can avoid the non-const globals, then I want to do that. But that is then the question is still, yeah, how are you going to fill this? Because filling these two was not a problem, but this one, that is really going to require a constructor. So then we get code that is running before main. It is not very nice. Maybe just make a. Why do I have this? Why does this have to be a global to begin with? And this is my initialization. So yeah, I might as well require this code or make a function for it, but then it's still global. So I think I should just declare it in main here, variables. There's no reason for it to be a global. Let's move this thing to main. And the variables index was moved, I think. Yeah. Well, actually, it was moved. Huh? What? Why is it now here? What the heck? Thought I moved it. Well, there's a floating point around. Oh, yeah, no. Pff, well, whatever. So that is in this namespace, really. The variables index. And variable itself is not, because, well, it could definitely should be, now I think about it. That's only using variables index, so let's just move that as well. How many other things can I just move? I can't move this because that defines the variables that the user wants to use. I could move this, I can move this, I can move this. Well, I can, but then for each variable has to be declared before that header. Maybe should not do that one. Yeah, I'm not sure. Declare variable. It's also variable. So we call initialize on the objects of this array. That is the variable here. Because I don't, well, now I make it here. Wait a minute. You could just initialize it here with an initializer. So is something. Could do that instead of this. Would it be more clean or wouldn't it? Let's try that. Sure, this thing can be constant in that case. Of course, we assign it directly. Because a variable takes a variable's index. See, that's kind of weird. Why is Copilot passing variables C0 here? That won't work. Well, maybe it should work. That would mean that I store, well, at least I have a constructor for this thing that takes a variable's enum then, instead of a variable's index. Gonna make sense. Slightly confused there. Does this compile? You use name and symbol without. I usually use underscores here, just to be able to do something like this. Guess we should try it out. Okay, and now I'm completely lost what I was doing. For each variable, declare symbol, so I don't have this anymore, or what? Wait a minute, declare symbol. No, that would be just a symbol directly. So I don't want that to be there anymore, right? But I do need a name. It's not this one, declare variable. That's what I wanted to use, yeah. So we don't have symbols, but I still need declare variable. It's not being used, no. Yeah, let's use a variable here then. Don't have that anymore. I think it's time to try to compile this. Let's make a thing here as well for each variable. Declare variable. Yeah, no, we can't do that because I already have that here. Let's call this create variable on. Now it's not being smart. Create variable name must be this thing here. Variable's name, stringified name, blah blah blah, 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 blah. Okay, so that's just this thing here. Okay, I don't know anymore. I lost track, so we're going to compile. Because of course nothing wrong with almost equal. Suppose the error is in this header here. Why would that be? Floating point round all error. Ah, forgot to comment it out. No template named. Yeah. Let's move this to the header. Okay, this is bad. I edited two files through. Damn it. Added the wrong file. I created this one. Uh-oh. Damn it. What? So I didn't edit it. No, apparently not. Matrix, yes, I did. I did not like it at all. Neutron, epsilons, blah blah. Oh, wait a minute. Yeah, so 2. And then the header. I'm just going to demand that for each variable has been declared, I think. Otherwise you get a lot of code duplication, and the whole reason for using this macro is to avoid that in the first place. Yeah, it's mostly used for declarations, I think. I was using X, but maybe declare is better. It's a bit, could be anything, so it's not always a declaration. And I escaped that wrong. What the hell? I'm just gonna call it the X. Must be a sign. No, I mean, I have what? Oh, that's why. My make file isn't updated. I finally understand the confusion a little bit. Yeah, make list. Yeah, it's sooner or later we have to get rid of the template. So let's delete this line. But then the number of epsilons, so that this should become a vector in the end. Because we're going to make it dynamic. Why would number of epsilons be passed here? Oh, wait a minute. That's part of the type. Array? First order array is being passed here. It's a private thingy. Okay. Maybe we should just use a type for the whole thing. A first order type, as it were. What bullshit is this? Let's put it back here. First order type, utils vector. Symbols, expression, pointer, epsilon, blah blah blah. Yeah? Yeah. Okay. First order type. Oh, these are epsilons. Yeah, we should not have those anymore. Wait a minute, we're expanding. Yeah, so that's going to be part of the manager object, which I didn't write in. Yeah, I'm just going to need some utility that is able to print subscripts. It is the last one. Let's say I'm not really in the mood to add a new utils function right now for this. It is not it. Looks okay. Maybe I just should try using no, I should not need to do this anymore. So I don't want to have anything to do with epsilons. Nor, of course, with that. Or this, for that matter. Well, we could compare it. And I think that this file has been cleaned up a lot. We just say which variables we have, and then we include that header. This is just for debugging, So I can print both a symbolic expression as well as a floating point round-off error expression from the debugger. And in main then we have the variables array. And easy to use abbreviations for the stuff, like the C3 and the X here are coming from here. Oh, damn it. Now what? The variable cannot be printed. Well, maybe I should add support for that. For debugging, always want to be able to print absolutely every type. So that would be in here then. Just name. Shall I print the index as well? Just name would do, of course, but the index is. No, let's print it. I mean, it's for now, you know, to check if things work. Yeah, let's print the index. And then I guess you can also print the symbol. So, no, that works. So we have C0 with index 0, and the symbol is also called C0. And then the same for C1 and C2 and C3 and X. And besides that, we can also print them by name, like for example X. That is an index, so it just prints the index. No, that works. Then next we want this to work. And yeah, the most important thing is that I don't want to have to pass anything anymore here. So this would just construct a new object from now something that is FA to begin with, because we don't pass the epsilon anymore. So this is now the copy constructor, and therefore I might as well use assignment. Let's say we do just auto that should work exactly the same. Yes. Might even compile because it's just a copy constructor. Oh, wait a minute. Make. It's not compiling. Oh, it's a variable index. Yeah. Now I'm trying to compile to variable indexes. That's not good. Yeah. Okay. Well, that should work. So let's add it. Multiply with an expression that does not contain epsilons. That would be, for example, a symbol. But then we are multiplying an FA with an expression. Do I have a friend operator that multiplies two expressions? Yeah. This multiplies an expression with an expression. But now we're not passing an expression, we are passing, well, why am I calling that FA? It's just so ridiculous. Oh, that's confusing. Yeah, no, the expression is the FA, and we have a symbolic expression. So I'm looking for, really for a friend that takes two symbolic expressions. Might not exist. Nope. So it's plus minus multiplication here. Yeah, I don't know where to put it. Let's put it here. No, I can't do this. Sorry, I can't. You can't. I mean, that does already exist. If you multiply two symbolic expressions, you get a symbolic expression. Well, I really have to work with the indexes. What is the variable index? That is a variable index. Okay, that definitely sucks. Because I don't have access to my variables array now. Because I put that one in main. Yeah, I have to make the manager object. Let's not do this yet. Let's just make a manager object. No, it doesn't know. I couldn't guess what I wanted. The expression manager definitely needs a reference or something to the vector with all variables. So that would be I have a type for that, I think. So it's utils vector variable simply. And then let's make a public. It's filling in a shitload of stuff now. Yeah, maybe the whole vector should be part of this one. And I don't need it in main anymore. We do have the for each here. Let's see what it all generated. A lot. I don't know what that is. Okay, this is getting confusing. This so instead of declaring variables here, I want to declare the expression manager. And that can do this internally. Create a variable is also part of that one. Yeah. So delete this now. Put that in the expression manager. It's an array. Maybe we should make it an array then. That is possible, isn't it? I have also a number of variables. Yeah. Hardly believe. I think that this should be a bridge. Sure, I don't think I need it, but why not? It's a const accessor. I think it's pretty cool that the Copilot filled in this AI never reached. It's pretty cool. Yeah, the why not function. Print all manager, just print all variables. Yeah, yeah. Except I don't want to print new lines really, because for debug output and stuff. The way I would do this is more like this. Mm-hmm. Yeah, yeah. Also, awesome actually that it is using void print on, which is my system ish. And I know where it learned it from, but I think it just learned it from this very code. I cannot imagine that it was pre-trained enough. Well, maybe it was pre-trained on my code so much that it knows that this works, but still. It's just using print on, which is pretty cool. Okay, yeah, we have a manager which just wraps the variables array. Nobody knows where that will go wrong, but still can't multiply variable indexes. Let's see. I think at the still not working, is it? There is no way to get my expression manager. Huh? I'm afraid these things can't be indexes. It's just not enough. We need the pointer to the expression manager. So whatever this is declaring, it should not be an index. Okay, wrap around the size type. It should be something that can also include the pointer to the expression manager. Yeah, maybe just make it references that point to the array. So instead of each variable being a variable's index, I'm going to make it a variable const reference. Initialized from the expression manager. Then we need a const reference to the variable. Get variable. Wasn't that what Copilot came up with? And then why name? Why not? Well, the only thing we have here is a name. Or I can make it an enum. Why not? So did that work? We can, yeah, it's like literally here. So you can pass an enum and then it returns a variable const reference. Can also pass the index, but we don't have that. We just have the name, so you can have either the enum or the name. So you could also use this, but then you just get the index. Well, at least with this code. But yeah, now this macro uses expression manager, which is kind of sad. I wish you could pass this as a second argument to the declare variable here. So name, comma, and then the expression manager, or let's use it, it's called manager as it were. And then I want expression manager to be passed to declare variable as a second argument. But declare variable is just being passed like this. So that means that, say, we just pass expression manager here as a second argument of the for each variable, which then has to pass that as the second argument to the declare variable. Yeah, and then the burden is on the user again. It is not nice, of course, because this has to be defined by the user. So either I want the user to define this with variable argument macros, or how the hell do you call those? Or no, I don't. Let's not do that. Okay, so not passing this. Undo. Oh. So now they have turned into variables, these things, instead of variable indexes. We can work with that. Well, so we can convert the variable into a symbol. That is, I think these are pointers, right? So the variable struct as a symbol pointer. And we can multiply, I think, two symbolic expressions. No, I could not. Ugh. Nope. Construct these with an epsilon in, no epsilon, damn it. Or, no, actually, the R, that is an expression. We need this. Hmm. Yeah, yep. So the expression is just that multiplication then. So expression times symbolic expression times symbolic expression is this symbolic expression. And that is going to be stored in the 0 order. The common denominator is going to be 1. And the first order is equal to the pointer to that expression, by definition, with the correct epsilon index. The only problem is that we don't have the epsilon index, but I should just create the next one, which we can get from the manager. So that the main problem here is now that we have to access the manager somehow. Then we can do this. So you have to dereference these things, otherwise they are just pointers. So this is a symbolic expression, this is a symbolic expression. Multiplication gives us a symbolic expression, which you then store in the zero order variable. And we use a 1 for the denominator, and then here comes the first order. And the first order is we can't do that, first order. So we have to do well, maybe I should just use the existing constructor. Maybe I should leave the constructor alive, as it were. So that would be this constructor, I think. Or this one. What's the difference? Oh, this is an our expression. So it's this one. So I need to pass an epsilon index type, but we don't, because do I need that? Do I want that? Yeah, probably. Yeah, probably. Yes. Okay. So I need to get the next free epsilon index type from the manager. And then the common denominator is already 1, and the zero order is just set to the expression. So this is what we want. And then, yeah, totally what we want, this one. In other words, working here. I'm gonna call I need a manager. Manager dot next epsilon index. I could do this, but maybe I should use accessors. This kind of reads a little bit hard. All those stars. What do you think? Wait a minute. Yep. I don't believe this works. I don't. It's can't work. Yeah. So if I want to do this, then I really have to start adding thingies at the end. too lazy to look at that. We'll just use the compiler to find every instance. Non-member function cannot have const. Qualifier. Use of undeclared identifier manager. Oh yeah. Manager. Where do we get my manager from? Well, from one of the variables. Because they should be the same. So can you choose var1 manager? And then of course it's a function. Or well, in the end, maybe just change the bloody struct into a class. And then I suppose theoretically I have to make sure that var2 has the same manager. I'm just going to compare pointers here. No, we don't have a manager. Okay, so fix that. That's not what I wanted. Oh, actually, it was here. Expression. Let's use expression. Yeah, so we have a struct, a variable. Maybe should make it a class. I'm already accessing these things directly. They are being constructed with a real constructor now though, so maybe you should make them const. So they are public, but if I make them const, then I really don't need to worry about the fact that they are public. It's no difference from being private and then having an access for them. And you need to add a manager, which is defined below. Expression manager. No, yeah, it's for declared. Something is not sitting well here. The reason I use a pointer was that then I can change it or assign it later. I mean, why not use a reference if it is a const pointer anyway? Not a good reason. If this compiles, then maybe we should change this into a reference. A reference being basically the same thing as a const pointer. Also, we need to initialize the manager now. No. And then here it doesn't fill it in. Why not? Just I have to delete it and then it fills it in. Stupid. Okay, now I have to pass a manager to the construction of the variable, which we are not doing. So if you compile it, I should get an error where that has to happen. And it happens apparently here. Or here. To create variable, yeah. The variable to add a manager, which is called the expression manager, which again could not be passed. So I just hope that it exists. Oh shit. That's not gonna work. So yeah, this. I think it did that. Didn't do that like in the beginning, and now I didn't see that it was correct. Next epsilon index. You don't have that inside a manager yet. Yeah, well, it's not a variables index. It's an epsilon index, I think. Nope. Damn it. What was it? I call those things like this. It's just this. Okay. Let's repeat that here then. Something. What shall be public? Public. And then this must return epsilon index type. And then I just return next, I think. Next epsilon index, yes, but it has to be incremented afterwards, I guess. Yeah. But this is dynamic. It's growing, so it can't be an array. It has to be a vector. And expression doesn't exist yet. Yeah, let's just make a epsilon index category or whatever. Epsilon index category. Hey. As it should be. This is a vector. Maybe a vector index and array index are interchangeable. Why not? That's why it compiled still. Cannot increment value of type const epsilon index type. Yeah, that's because this const. Still not const. Oh, and I have a const pointer to my manager, of course. This argument to member function is type const. Yeah. My manager can no longer be const. So var1. That is a bit far. I mean, I'm not going to make my variable non-const just because the manager has a deep down and epsilon index that has to be incremented. So instead, we're going to keep the manager constant. No, actually, I could store a non-const reference. Maybe that is better. Probably better. Either that or make that index thing mutable. Maybe that's better. I mean, my expression manager contains more than just... Yeah, it contains the whole variables array. Okay, that one is const. And so, yeah, either way, I guess. Yeah, let's do it like this. I'm not super fond of non-const references, I have to admit. En still we can't multiply them. En wel om te binding expression, variable and variable. Why? Should that not just call this? think it should. Line 182. Doesn't even talk about candidates or anything. Let's be explicit. No member named operator star in namespace floating point round off error. What the okay, so the friend is declaring it, and we can't find it. So maybe it's not declared where I think it is declared. So let's for declare it and then call it a friend here. And I had expected it to end up in this namespace, just before here. So if I forward declare this thing, which means that we have to forward declare that as well, then what will happen? Oh yeah, then it just compiles, of course. My friends, or at least these friends, are a bit weird, if you ask me. They don't do what we expect. Well, then I suspect that to be true for every friend that I declare. Man, we have a lot of them. I treat it as an array, but it is a vector now. The vector is empty. Oh. No. Forgot to declare it. Yay. So now we can multiply two variables basically, C3 and X. And yeah, well, this is correct. And it introduced epsilon 0 itself. So let's see what happens if we extend this. Well, I know I should be able to get rid of this, of course. 3 times that. Let's add one more. And this thing, we should be able to assign it from just this formula. Yeah. Yep, we don't have a plus. Why do I not have a division? It should have that as well, of course. Yep. Totally correct. No. Construct? What do you mean construct? Wake up. Okay. Okay. No. That the Copilot thing is actually saving me a lot of typing. Definitely. And the other friends that we had, yeah, the multiplication. Let's put them in the order of plus minus. No. No. Well, yeah, actually, does inverse even exist? I don't think so. There's no inverse. It's made up inverse. It's hallucinating an inverse. I have to agree that this is problematic. There is no inverse, indeed. I want to use another operator. Slash. This one. So the only one that I have is yeah, one that can divide two expressions. So vision is hard. Feels like I have to do a code duplication here though. Just copy this and then make the necessary changes. Let's begin with this one. If I did not make a mistake, then this would be it. Now let's look at it from here. Does this make sense? The zero order expression is the argument times the zero order of the what we want to divide by multiplied with the common denominator. Really? Well, that would be the FA zero order divided by the FA common denominator? No. Yeah, well, I'm dividing by the zero order twice. So basically this is arg times FA common denominator divide FA zero order. In other words, it's arg divided by FA zero order divided by FA common denominator. Wait, this is what it should be. Yes. And then we run over all the first order thingies in FA. And if they exist, and we subtract minus arguments. So that's we subtract not. Yeah. Add the minus argument. So we subtract argument times that first order times the FA common denominator. Yeah. And I probably should do this part as well while I'm at it. If F2 is single. Yeah, that means that FA first order equals FA zero order for that particular epsilon. So we can divide everything by FA zero order, above and below. And then here we also have to divide by that, but there is no zero order, but the FA first order is the same thing. So we can just delete this now. Well, that should work. And I did something wrong with the grow first order. Maybe it should not even need to be mutable anymore. If I just, this is nonsense. Oh, well, actually not nonsense. Wait a minute. That is the current first order, yeah. Well, this should be results. And this is should also be result. This is results. Now this is in a non-const constructor. This too. The other one work on non-const result objects. So we can just make this thing non-const. Right. And then we can get rid of the mutable. Variable comma expression. Uh-oh. Yeah, we have two variables, but not a variable and an expression. Hello, bot on C++. Variable. So we need a friend for the variable up front, but not for the expression up front. You need those. I need to implement those, however. You changed your name. Oh no, diversion. Let's move these up to above the multiplication. Above multiplication and division. Yeah, these are the swapped symbolic expression and expression. You need the same thing for variable, basically. We get negation, zero order and the print on. So these are friends. They are defined below multiplying, stuff with another expression. Maybe I should move to make more sense to put them below this. So this is floating point round off error expression, and then operator with symbolic expression. And then if you swap the two, you get blah 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 blah. Scroll these. And then I need the exact same thing, but then with a variable instead of symbolic expression. We can put those below the ones that now work on just a variable, which we don't have. I just have two variables. So we need both kinds, yeah. Basically you need both kinds. We can add the friends already. And then rename the expressions to variable. This is a horrible code duplication. You can just use the other one. Of course. Return our symbol. What a bullshit. Divided by FA. Symbol returns a reference. Yep. Could do the same thing here, but yeah, maybe I should. maybe we should do that. I could swap them already, however. But it's not the real reason not to already take the symbol from of it. So I swap and I take the symbol. While I'm at it, I'm going to rename the arg, I think. Nothing much commutative about this. It's like totally not commutative. This one neither, actually. The whole comment is a bit weird. Yeah, now what am I missing? Now I'm missing working on the non-friend stuff that works directly on variables. And we have to add these as friends, I think, also still. I mean, forward declared. They are friends, but I must forward declare them. Let's put them here. Why the hell is it suggesting that this is const? Oh, because I'm returning an expression. Yeah, it's correct. It's correct. Okay, let's delete all of this. Oops. Division. Right. Yeah, just convert the variable to a symbol. That should do it. No, shocking. Even compiles. What about that? C2 plus C3 times X is C2 plus C3 times X times, and there is no epsilon. We lost an epsilon. What the hell? This whole thing should have been added, multiplied with epsilon 1. And then that one drops out, so we would get this again times epsilon 1. It's missing. Why? I don't know. No, let's run the stuff in GDB. We are adding FA plus var symbol. Well, that's strange because this is var. Oh yeah, of course, it just switches it. So the var here is the C2. Call print C2. Can I print C2? No, I cannot print the C2. The C2 is the variable. Let's just print a symbol. That should work. And that's C2. Call print FA. We can print that one. That is C3 times X plus it's stuff. That's the previous one. It's the C3X. So far so good. We're going to add them. Okay, I'm starting to have a suspicion here. This plus is not adding an epsilon. Those operators never did. They never did. Yeah, so X is a symbol. And this is my plus operator. Okay. Quit. edit. Slightly confused. Why does the other one work and this one doesn't? The other one being two variables. Because then I use this constructor, which is just the zero order thing plus a next epsilon index. Do it in 2 steps. Could use this one. But it seems kind of silly. I would have first constructed with well, this is basically a copy constructor. So why would I first construct it and then copy it and then do this? So the constructor that I'm using right now is this one, I think. So I could just extend this one. Add an epsilon index to these. I don't think these should be public because I don't want the user to be annoyed by, bothered by any epsilon stuff. So these should be private now. If you pass epsilon index, now you have a symbolic expression with an epsilon index. And there is absolutely no reason to pass the common denominator at all, actually. I think. Could pass it, but probably never going to be passed. The thing is even private now. I think what I should do is check if the expression is a division. And if it is a division, then split it up. Whatever is being divided by, put that in the common denominator. That makes more sense. Anyways. Tja. Okay, let's just no. This. Yes. think I want to see which constructors are really needed and or where they are used. Let's comment all of them out. Let's see where the compile errors occur. No matching constructor. So this thing tries to construct something from a expression and an epsilon. Yeah, we definitely are using that. Symbolic expression, I mean, of course, or this one. Yeah. Let's just work with pointers. Yeah, that won't work. See. Or will it? Actually. Yeah, I think it will. Hmm. Yeah, I don't know. Think there is a problem here or not? No, this cannot be a problem. I do that and that gets assigned. The only problem is that this for loop loops over the new epsilon then. Which means that it gets multiplied with argument again. It's not what you want. That is the only thing I don't want. How to work around that? But a constructor is a constructor, isn't it? It's not thread safe, but I never said it would be. So of course the whole next epsilon index thingy is very not thread safe. If another thread calls this as well, then you are fucked. But in particular, we would be if it would be called in between this call and actually using it here. Or is that nonsense? It's actually nonsense. Still thread safe, because no thread should be messing with the same object anyway. This object at the same time. Yep, good. Well. And there's a construction here. And here we have again stuff. So bloody friend is. Let's be FA. Do I even have an accessor? How does it even come up with that nonsense? The whole grow should never be necessary anymore, because it's being grown here to build any existing epsilon. The whole result grow is well, should really delete it, I think. Everywhere. Still, it doesn't know what I want. No. Why? Even an I here. This doesn't make any sense whatsoever. New epsilon. What? New eps. Oh, wait a minute. No, new. No, I got it. No, we're done-ish. It's just a print. Okay, so I had a grow first order. On result, it seems kind of nonsense because I'm now constructing result with the next epsilon index. Just want to okay, so this is one that takes the zero order, first order, common denominator, and next. What? I thought I added it. Maybe I didn't. Guess I didn't. No, I didn't. Then that would be, yeah, this one, sort of. This one. Exactly this one. So we have a zero order, a first order, the common denominator, and the next epsilon. Now we make a copy of that. Zero order, first order, common denominator, and then we have to multiply the whole thing with 1 plus that epsilon. Which means that it always has to be grown, and then it always is 0. Might as well remove the assert. Maybe we should pass the manager instead of a new epsilon index. Then it can generate a new epsilon index here, and then I'm sure that it will be a new one. It makes much more sense. Much more sense. Except that I don't have to pass it because this very object. No, of course I have to pass it anyway. Yeah. Hello. Okay, so let's first fix this one. This was. It's okay already. Of course, we are constructing something with an empty first order. And then just copy the first order, multiply it with arg. Okay, what's the difference? What is the difference? There's no difference. Well, this one doesn't have a default common denominator. But I might as well use this one then here. Symbolic expression. Comma. Nah, okay. Yeah, the common denominator is the one that is lost. Let's just delete this one, because if by the time I am using it, I should just use the other one. This is the one without a common denominator, and this is one with a common denominator. Oh, wait a minute. Should I use the... That has to be used. Okay. compile. But yeah, instead of passing the epsilon index, we should pass a manager. Definitely, totally, 100%. Let's pass the manager as a pointer. So I'm gonna do here epsilon manager pointer manager. Damn it. Yeah, I've got that one. And this is first. Hmm. Yes. Same thing here. Don't want to have an epsilon index. You want to have a manager. Special manager pointer. And then everywhere where I passed that, I should have passed just the manager. In other words, from here all the way down, substitute that with nothing. Oh, that didn't work. So I don't have a new epsilon now here. I must have, just get that from the manager, I guess. Lost epsilon. And then we have to add the last epsilon to the manager. No. So 1 is 1. It is called last epsilon. Maybe I should have called it the last epsilon index, however. Percentage substitute last epsilon. Last epsilon index. It compiles. Let's try to run it. And fixed. This formula is fixed. C2 plus R, yep, and then that whole thing times this times epsilon 1, and then the C3x times epsilon 0. That's absolutely perfect. Now let's do the next one, why not? Wait a minute, what was this thing doing? Variable in the air. Hello, we have to edit it also. Auto, that thing becomes this times that. Pretty sure that's okay. Now let's make it beautiful. Auto FA is it's not exactly how I want to calculate it though. Still want to do the multiplication with x separately. Plus I don't have an to the power for the FA object. T0 plus something times x, that times x, that everything times x. Okay, that looks good. Much better readable than the shit above, right? No, so I can delete all of this, I hope. Let's print it. Five epsilons, and the first one is epsilon 0, is the last thing, and then the epsilon 1 gets one thing extra. So that is correct. And the next one is, it should be the same, so yeah. And then we get one thing extra, so the C1 times X is added to this, and that's used here. And also here. And this is the whole thing. Times epsilon 5. This is perfect. Okay, and we can do the same thing with this one. Auto dfa is have a derivative. Yeah, I wish, but yeah, I can make that work, you know that. But then I have to make my math library a template first, so it works with arbitrary types instead of double. And then you can just call derivative on derivative on the zero order expression of FA, and that would give exactly what we want here. But instead, let's just use the formula, which is this, basically. But it must be times 2, and it must be times 3. That would be the derivative. Yes. Now I have a slight problem because I'm multiplying with an int here, which is not supported. And I want that to result in not adding an epsilon. Oh man, of course I want to print DFA. Let's remove all of this because it's gonna work. Yeah, it should not compile because the integers thing is not supported. Can't int times variable, and then the 3 is also int times variable. Okay, let's add that then. Oh, there must be a friend as well. If you had to put the int up front. Ah, what the heck. I'm going to make it a non-friend. I'm going to return a symbolic expression, I think. Multiplying an int with a symbolic expression, no, with a variable. just make it inline because I'm not going to add a .cxx file with that. Yep. And just multiplication. Maybe I should support adding, however. Adding, subtracting, division. I don't know, man. This is enough for now, because it's the only thing I need. No, it's not. No, it first does that thing. That's an expression. Huh? What? Expression number. So 3 times C3 is now an expression. What kind of expression? Oh, it is symbolic. Never mind. Candidate function. Variable known on conversion from const expression to const variable. I think this expression is the symbolic expression. Bad compiler to print it like that. So that won't work then, unless I add support for that. Yeah, I guess I just have to add support for that as well then. So, since we can have a left-hand int, we now also need a left-hand symbolic expression with the variable. Wait a minute. This now is an expression. Nonsense expression times var symbol. Yeah. Yes, of course. Of course. Okay, so now this is, it was a var, but I'm turning it into a symbolic expression. Same thing with this. Therefore, this var is also eaten. Symbolic expression, symbolic expression. Now the whole thing is symbolic expression. And then times x is the whole, this is now a symbolic expression. That's not how I envisioned it. It's not correct here. And this one was correct, but that one is not correct. I should this should definitely return. It's not an int anymore, so yeah, they should return an floating point round off error expression. So it was wrong. Okay, let's turn this one into a friend then. No idea where to put it. Just put it at the bottom. It's below the last time we used variable, which is probably here. Friends. Is that correct? It's not a bad guess, I have to admit. I don't think we have this constructor. It would be expression comma manager. Yeah, this one. Do have it. This is not used apparently. So delete it. Quickly delete it. Never look back. Now, okay, C1 plus 2 times plus 3 times, etc. This is the zero order thingy. So that is the exact formula. And that exact formula has to be multiplied with epsilon 9. Yep. And then 8 is the exact same thing without the C1. And then repeat it. And then this one is without this term. So that's just that. Oh yes, it is correct. It works. Then we go here, huh? Now I have this problem here. The FA here is adding epsilons, which I don't want for this particular case. But maybe I can just circumvent that by... No, I can't. Damn it. How do I do that? I did build in. All my binary operators now insert epsilons. Well, actually, not. It maybe it's not a problem if I just ignore those epsilons, because there are going to be the last two epsilons. I'm setting every epsilon to 0 anyway. Well, that's only for the evaluation, of course. I'm still calculating the derivatives with respect to C0, 1, and 2, and 3. And then we demand that it might work, you know. Just see if it works. So I'm going to try to compile it. That would be the first thing. Yeah, it's not working. Oh, you can't even assign the thing anymore. Yeah, x used to be a symbol. Now it's a variable. But I can access a symbol. Dot symbol. See what that is doing. See if it compiles. Yeah, it's bloody 16.5 degrees here. Wow, my feet are cold. No, it's too late to heat up the whole house, I must say. I should just go to bed, I think. It's 11:30. Before my feet get even colder. Yeah. Okay, I'm gonna stop, I think. Been at it for a while. Let's lose 1 or 2 games of chess. I'm definitely not going to win. My rating is plummeting again. It's unbelievable. Well, it's not unbelievable. I'm just really stupid. Took the knight. Let's develop. Let's develop. Let's develop. What a weird move. It makes no sense what this guy is doing. And still I will lose. No worries about that. I should ask castle. Castle. I more or less have developed now. But seriously, this guy is attacking as if I played the dragon, which is with the pawn here and my bishop here. He's just doing all the moves that belong to the dragon. But I didn't. My pawns are still here. Yeah, free rook. I wanted to move the knight anyway. It's made in one, dude. No, beautiful game. I won. Finally. Yeah, that was really too sad for words. French, I mean. I hate French. Really hate French opening. He's not really playing French though. He's doing all kinds of weird stuff. Shall I? Yeah, I don't really want to lose this bishop, I have to admit. Could put it here. There's the French opening. This one or this one. I need this knight over here, otherwise I can't castle. It was already protected, but well. It's overprotected now. I've defended 3 times. It's only 1 time attacked. So there is not even a fork with the queen now between this and this undefended pawn. Not to mention that the bishop is in between still. I get a free pawn? No, if I take here he takes my center pawn. Okay, let's not do that. But I can threaten to do it. Should I move this pawn up? No, let's make haste with castling. Takes my knight. Okay, I developed the queen. Still having okay, I've now moved my queen and it is a fork. That is the true. Take, 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 take. Then the queen is here. Yeah, it's not working for me. Wait a minute, I get 1 extra move. I can just go here. Take, take. No, I can't. Damn it. I could take with the knight, and then I can give check here, but I'll just take the knight. I can't go here. I just also take the knight. Wait a minute, that thing is here. Yeah, but he can't go there. It's no check. I have to move my queen. So my queen moves. Let's say there. And then I attack the knight twice. Or I can put the bishop in between then. Okay. So I would lose a pawn if I do that. I think I'm gonna take with the king. Oops, I didn't see that one. I'm now losing my pawn anyway. He retakes. I move my king again. Not all is lost. Yeah, with the bishop here. This. Oh, what? Why? He could have won on pawn. I should have put a rook here. I won't put my bishop here. Then I'll lose that one. No, I don't. I don't. I wish. Take my pawn. I think it's time for my knight to go there. This is also a nice weak pawn there. A nice weak pawn. Ah, he's running away already. Let's go here because that is the open file. One, two, three. Good thinking, good thinking. Definitely sucks. I don't want to take there, you know? Wow, that's a good move, man. Again, had not seen this one coming at all. Well, I'm pretty sure he could have won that pawn here. He did not want to. Did not want to win the pawn for some reason. I did win that pawn. Did want to win that pawn, I mean. It pretty much sucks, I have to admit that. This is bad. I just gave away a rook. No, of course I gave away a rook. It's that time of day again. I have to give all my games away. Why? Oh no, I gave away queen. It is protected. Time to resign. So bad. So horribly bad. Okay, I'll play one more. I'm gonna win this one. I sure hope I will win this one against 1789. What to do? Take the bishop or not? Definitely annoying. It's protected, man. Not to mention that it just doesn't make any sense whatsoever. Oh. The queen comes in here now. My king is suddenly extremely vulnerable. Can I still run away? Oh, maybe I can go here. Yeah. Oh, you cannot give check here. Oh, I cannot give check here. I can only give check here. And then I go there. Threaten to change queens. This must work. And hopefully I can just run away. There or there. No more checks. Yeah, my queen can give check here, I think. Definitely can force that king away. Oh, well, that's a possibility. Let's just take it. Nah. I had wanted to enjoy that more. My tick. Now white is mate in 7. So the computer starts to giving away rooks. Or queens, or knights indeed. Every move, every shown move is giving something away. So suppose it's doing nothing like this. That's also horrible. Mate in 2. Doing nothing. I think that's not that bad. Because then I can't give check here anymore. After taking the pawn. So you give check, it goes there, go check again, it goes there, give check again, it goes there, and now we have a problem. Check. I made, yeah, that's how it worked. Okay, good night. Totally going to bed.